start recording and we will go through the homework. And hopefully the Wi-Fi is now stable enough to get the homework done. So if we look at our static electricity, the one that was due for today is charging by induction. The electric field one is coming up next. Yeah, you know what? If the Wi-Fi is bad, I'm hoping that the homework module completely loads and runs in browser. So I'm hoping that even if we lose the Wi-Fi, I will be able to continue doing the homework and then I can upload it later. So that even if we have a hard time doing it live, you still have access to the answers. Okay, so let's get started. Charging by induction. Now, once you are comfortable with this homework, you may start the lab. You've all got access to your whiteboards. They were all emailed out in the last class. But because of the level of difficulty people were having, today I'm going to go through all three levels. So not just skip to the wizard. I'm going to do apprentice and master and wizard. So you can follow along for as long as you need the support. Or you can start the lab and come back when I get to wizard. Right, totally up to you. So let me go through here. I'm just going to reposition that. Yeah, it was hard for a lot of people. Like I said, only one person achieved the trophy. So, a neutral aluminum pie tin is charged by induction. So step one, Garmin, you should know me by now. I'm not going to name names. So step one, the neutral pie tin is brought near a negatively charged foam board. While the pie tin is held near, it is touched by a finger. The result is the pie tin becomes charged. So if this is negatively charged, when we touch it with a finger, right? So that's the negatively charged foam board. While it is nearby, we touch it. This will ground it and equalize it. So these negative charges are trying to push electrons out of the tin. When you touch it, it's grounded. Those negative charges go through the person. So you've taken electrons away. Afterwards, it is going to be positive. Right? So in this one, so the electrons within the pie plate, so electrons in the pie tin move away from the foam board. That's the polarization step. Then when you discharge it, the electrons move from the pie tin into the finger, so it becomes positive. So now we have a balloon, so we're charging a metal sphere by induction. A positively charged balloon is brought in, and it's grounded. So when the positively charged balloon comes, remember, only electrons ever move. So the electrons in the sphere move away from the balloon, and then these electrons will escape through the finger, leaving this as a positive charge. Or sorry, it should. No, hang on. The electrons are going to move towards it, sorry, because that is a positively charged. So then extra electrons from the hand come in, because it's trying to stay negative. So that'll be how it gets a negative charge afterwards. Now when we have a negative charge here, that is going to take the electrons within this sphere and move them away from the negative charge. And when we make contact, those electrons escape through the finger, leaving us with a positive charge. And now finally we have a positive charge here. The protons never move. It's only electrons that move. So the electrons in the conductor are going to be drawn closer to the foam pie plate. And then when you touch it, electrons are going to come through your finger into the pie plate, leaving it with a negative charge. So are there any questions about apprentice level here? All right, we will try the master level now. So we are charging a neutral metal sphere by induction. A positively charged balloon comes near the metal sphere, which is going to cause the electrons in the sphere to move to the side that's near the balloon. While the balloon is heading near, another neutral metal sphere is touched, which will redistribute those negative charges. So we've got a lot of negative on this side, it means it's positive on that side, the negative comes in. As a result, we get that negative charge. So now we have a negative brought near a neutral metal sphere, which is going to make the electrons in that sphere move away from that negative balloon. And when you make contact, you allow their escape. So again, we have, in this situation, the electrons are going to move within the pie plate to be closer to that foam board. They don't escape the pie plate, they just stay within it and get closer. So then when you make contact, more electrons will come to fill that gap. So last one here, the electrons within the pie plate move to the other side of the pie plate, and then they try to escape completely when they make contact. All right. So that's the master level. Any questions here? So, and then this one is essentially review. It's the same 8 questions over again. So I will just quickly do that as a recap. We bring a negative balloon close, and the electrons within the sphere move to the other side. If we give them an escape route, then they will take it. So here, when they're positive, the electrons within will move close to the positive. So you give them a way to come in, and they will take it. And the electrons move away from the negative charge, but they are still within the sphere until you give them a means of escape. Maybe I should have just done the wizard level because it's still... These are the identical questions. So because that's positive, the electrons are going to move close. And then they can pull in their buddies when they're grounded. Here that's negative, so they're going to move away. And if you give them the opportunity to move farther away, they will. Again, they move away, and then escape completely when they can. So then finally, the electrons within will move closer to the positive, and you give a path for more to come in, and they will take it. Okay, so that was the homework.